Hello everyone, welcome back to the video. So in last lecture we have covered lists, the topic lists. We have done everything about it. Okay, and we also did some program examples over there. Okay, in this lecture we'll be doing tuples, sets, and dictionaries. Okay, so as you know that list is like in the list you contain some information, some elements are there. So what is tuple? Tuple is like a built-in data collection in which like it is ordered and immutable. It means we can't change tuples. Mutable means that you can change, but immutable means you can't change. Lists were mutable, tuples are immutable. Okay, and you can we did lots of functions that can be used or modifying our list, but in case of tuple we can't just modify or add or remove elements from it. Okay, so it is all about tuples. And about sets, what are sets? So basically sets are also used for like storing data in them. List, tuples, sets all are used for storing data, but sets can also not be altered or modified. These are also immutable. Okay, these take unordered. All the things that are stored in it are unordered, but in tuples everything is ordered. Okay, and about dictionary is like it stores lots of information inside it. It is ordered, mutable also, and unique key value pairs are there. Like all the values are going to be unique. It can be changed, we can change the values also, they are mutable. Okay, and they are ordered. All right, so this was the introduction of tuple, sets, and dictionaries. So the building blocks of data, like how do we build data inside any like we are having code and all. How do we like how is data built? How is data managed and all? Ordered versus unordered. Tuples preserve insertion order, sets do not. Okay, this distinction shapes how you can assess or iterate through data. So basically, this ordered and unordered thing is only like helping us in like if it is ordered or unordered, we only know that how we can just use it, how we can alter it, how we can assess it basically. So tuples are immutable by design. We can't like change or put any changes in tuples as they are immutable. Once defined, tuple cannot change. So once you define it, it cannot change. Ideal for fixed records like coordinates or databases. So whenever you are using some fixed designs, something fixed that is going to be fixed throughout, uh, then will use tuples, as we can't change it again, right? And sets, uniqueness and speed. Sets eliminate duplicate automatically and offer over membership testing, mathematically elegant and fast. So sets will eliminate all the duplicates automatically. It is not going to take any redundancy like repetition of any element. All the elements are going to be unique by in it, and that is it. Uniqueness and speed. It uses this oven membership testing that is elegant and fast, that helps us check mapping the word with dictionaries. So hash tables under the hood. Dictionaries map keeps to values. For instance, O1 says Keys must be immutable. Lists and sets are excluded because the hash could change. So order tuples are ordered. Here is a little table for all of us to remember everything. Like tuples, see tuples are ordered, immutable. They allow duplicates. Index based access. You know what is index based access? Like we can assess the elements based on the index, like 0123, the indexing that we have done in the previous lectures. Okay, and then set are unordered, mutable, we can change them, unique only, there are no duplicates in sets. And membership testing can be done. Membership testing is like in and is that we have done earlier. And dictionary is ordered, mutable key value pairs, instant lookup. Okay, so this table you can just go through, just keep everything in mind, that how everything is different, these three are different from each other. Immutable sequence in action. So packing and unpacking, name, age, values and 30, assign multiple values cleanly in one line. In one line only you can assess multiple values to it. Okay, list tuple conversion. So how we can just convert list in tuple, like how can these be converted into each other? Convert with tuple and then the list name to lock data, or list my tuple to regain mutability. Just in the previous one, see, tuples are immutable, okay, and list are mutable. So let's suppose you just created a list and you want that no one could alter that data, and that should be like permanent. No one can have access to alter or modify it. Then you can convert it into a tuple. Just write tuple and write the name of the list. So data will be locked. But let's suppose you created a tuple and you put some mistake on it and you want to just change it. But as the tuples are immutable, you can't put any changes on it. So first you can just convert it into a list and then you can change it. So convert it into list, you just write the list and inside write the name of the tuple to regain mutability. The single one trap. The singleton trap. Always use a training comma. See, without it Python treats 5 as an integer. Always put a comma after it, otherwise Python will treat it as an integer. Like if you're having only one thing over here. So there are some set operations, power or uniqueness. Union. This long line that you see, that you put, is it depict like it shows that it is doing union. This sign is used for doing unions. Like you put A and then you put this and then you put B, all elements in either set. You know what is union, right? All the elements in either of the sets are going to be printed. Intersection, elements in both sets are going to be printed. Difference, in A but not in B. Like you are subtracting A from B and all the elements that are similar in B and A will subtract, will not come, but the rest of the elements that are left in A will be printed. If user ID in band set runs on open far faster than scanning a list. So here is advanced dictionaries beyond the basics. So dynamic histograms. Count word occurrence with counts word. Count get word, comma 0 plus 1. A classic text analysis pattern. So it is a classic text analysis pattern that was used, okay. In efficient iteration. Loop with dot items for key value pairs, dot keys or lookups or dot values for aggregations. So efficient iteration like that. Safe manipulation dot get, like just remember all of these things, that dot items, dot keys, dot values, because these we are going to use for the later. Okay. Safe manipulation, and this get also, this update also. Get is used to avoid key errors, and update for bulk of changes, and del or .pop to remove entries. You remember in last lecture we did pop was like for removing the data from elements from the ending by default, or you can just specify the number of index over there. It alters the list using the indexing number. Data structure in the wild. No fly lists are sets. Student records can be used as tuples. Contacts can be used as dictionaries. So no fly list. Security system used for ON lookups against millions of flagged identity. Speed is non-negotiable. Student records can be changed, cannot be changed. Like immutable tuples store names, IDs, and dates of birth. These can't change. These things won't change, right? Data that must never silently change. And the names map to phone numbers instantly. Thousands of unique entries, zero collisions, and instant retrieval. You can get instant. You can get everything without any collisions of data in between them, because everything stored is unique. Okay, so you can retrieve very instantly. Test your knowledge scenario question. You have a log of 1 million user ID and need to verify if one exists. Which structure will you use? Which will you use? Dictionary, value, trace type error. Which rule does it violate? Transformation task. Write one line of Python to extract only unique values. Like all these things you'll be able to do by the end. Okay. So this you can solve at the end of our lecture when you'll be knowing everything related to it. Now let's go to our word file for going into more depth. So, what are our learning objectives for this one lecture? It's like by the end of this lecture, we all will be able to understand tuples, sets, and dictionaries. Okay, and compare list, tuples, sets, and dictionaries. You will be able to compare all of these. Create and manipulate tuples, sets, and dictionaries. You can create them. You can also manipulate those who are immutable ones, so you can't change anything or manipulate them. Okay. Use common methods. Okay. Solve real world problems using these data structures. All right. So in the introduction one, data collection, Python collection, data types. So data type ordered. Here like it's written data type. This is the data type, and it is written if it is ordered or not. Lists are ordered, yes. Tuples are also ordered. Sets are not ordered. Dictionary is also ordered. This is the like version of Python written. After this, all the dictionaries were ordered. And changeable. Is list changeable? Yes. Tuples are changeable? No. Sets are changeable? Yes. Dictionaries are also changeable. Only tuples are permanent. They can't be changed. Duplicate values. Are duplicate values allowed in list? Yes. In tuples also yes. But in sets, no duplicate values can be there. Everything is very unique. Similarly, in dictionaries, like keys can't be duplicate, but values can be duplicate. So what is a tuple? Okay, So what is tuple? Tuple is an ordered and immutable collection of items. So it is ordered and it cannot be changed. It is immutable. Once created, a tuple cannot be modified. You can't modify a tuple once you have created it. Features. What are the features? Like this example is given. This or cannot be changed, and this is the what do we say? Syntax of tuple. Like put a comma, like brackets. Put inverted commas for this string values, quotes. Okay, and for rest just put inverted commas for the strings. Rest you can write it like that only, like the integers. And the features are given over here. The tuples are ordered, immutable, always duplicate values, allows duplicate values, faster than lists, and indexed. They are also indexed, and they are faster than lists. Tuple operations, assess elements, student, this is given, okay. Print student 0, and length, print for length you can print length and student count. Numbers, these are given, print numbers dot count. For index, numbers dot index. So let me go to online compiler. Here first of all we'll take a tuple name as student, and we put a bracket, we name it as Rahul, and put his age, and his course is CSC. Alright, so I'm gonna print and then put student in it and put 0. It means it is going to print its name, right? Because this is at index 0. Oh, I wrote student. Student. And for checking the length of your tuple, you're going to use length function, length, len, and put students inside it. And when you run it, 3, only 3 items are there, 3 elements are there inside your tuple. Alright, so what was the next thing? Count. How you can count numbers inside. You need to change a tuple. I'll write it as numbers, and I'll write lots of entries. 3, 4, 5. And in this, I'll just write print and then numbers dot count. I want to count the number of 3 that it is having. Okay, so I'll write that digit inside this bracket, and when I run it, see there are 3 times 3. Let's take for 7. There is no 7, then it should print 0. Yeah, and for let's check for 4. Only one 4 is available over here, so this is how we can check it. Okay, and if we want to know the index number of some specific number, okay, let's suppose I want to know the index number of 4, so I'll just write here 4 index, and then inside bracket I wrote 4. So 4 is at 6 numbers, 0, 1, 2, 3, 4, 5, 6. At 6 4 is available. The index number of 4 is 6. This is how you can do it. So here, what is set? A set is an unordered collection of unique items. It is not ordered, but all the elements in it are unique. Duplicate values will automatically be removed from it. It will not allow any duplicate values. Let's suppose the like here the syntax is given. For writing a set, you put it inside a curly bracket. Alright. Always remember the sets are there inside a curly bracket and the tuples are in normal bracket, lists are in block bracket. Alright. Sorry. So here are the features of set. Unordered, they're unordered, mutable, we can change them. No duplicate values are there. And fast searching, we can search anything inside the set very fast. Alright, so here are some set methods. It is mutable, so now we'll learn that how we can modify it. What are the functions like add, remove, and all. Discard, pop, clear, and all that we can use inside the set. First one is add. So here the first slide, let's write number dot add. What do you want to add? I want to add number 8 in it. Okay, now let's write print numbers. Now let's run it. Oh, it's not a tuple. It is a tuple now, and tuples can't be changed, right? I forgot to change the bracket over here. See, it added 8, and see, I put some extra 2 over here, 3 over here. It just eliminated all of them, and only unique values are here, printed over here. And I remove number 1 from it. Remove. Okay, and then the pop was there, right? Through numbers dot pop, let us write. According to the what we studied for pop in list, it should by default remove the element that is at last, so it should be removing the sixth number. Hmm. Oh, it is removing the first number. Let us write here 6. By default it is removing the first value. Okay. Okay. Next one was clear. Numbers dot clear. Oops. So here G and empty set is printed because everything is gone. If I just don't write this print numbers and the empty thing is here, nothing is printed. But I wrote print, so it just wrote a set over there. Okay. And some set operations are also here between two sets. What you can do is A union B, A intersection A difference, and symmetrical difference. So here A and B are the names of two sets, two different sets. Alright. And here we can just do union intersection. also find the difference like that. Okay, so for doing that we just have to write the name of first one. What do we say? Set first, name of first, then dot, then write union, then in bracket write the name of the piece. And then your set's name. And similarly, the same syntax for intersection, just write intersection instead of union over there. And then difference also same, just write difference instead of intersection. And then symmetric difference instead of this. Okay. And what is dictionary? So dictionary stores data as key value pairs. You are having key values, and the key and value pairs are stored inside dictionaries. What's the syntax? Let's have a look on syntax. This is it. But first you write student equal to, then see, this is key, name is key, and value is Rahul. First you write a key and then you put column, then you put name, like the value for it, then comma, then similarly you put it like this, and then you close it by a curly bracket. Okay, so let us create a dictionary. Should we? Let's just copy this one. See, it is done, it is created, but we need to write print student only, then it is going to do anything. It is going to show anything on the output. See, dictionary is printed as it is. Okay. Don't worry about these questions like intersection and in further slides, like when we go further, we have some program examples over there. We'll see to it and then we will run it on the compile. Okay. So assessment. How to assess the value out of the dictionary. So first write print. Obviously if you want something on the output you write print, then the name of the your dictionary, then you write the name of the key. Name was the key, value was Rahul. Okay. And if you want to add item to the dictionary, you write student and then in brackets you write city, whatever you want to add the key here, and you can write your value over here. For updating also, same syntax is followed. For deleting, then student, then name key. Its value will be automatically deleted along with it as they exist in pairs over there. Okay. So let us do this print. Okay. Let's suppose I want the name, age of the student. Print, then the name of dictionary student, and then inside it, I'm going to write this in box bracket. I want to find age. Now if I run it, see, age is printed, but I want okay. And let's suppose I want the name of the student. I write name here. Then put a box bracket, inverted commas, then name. And I run it in the ground over there. Alright. What if I want to add his city over there? I write student here. I'll put this box bracket. I write city. I could put equal to. Then I write here Delhi. Delhi. Let's go to the final one. I want the final final dictionaries having city Delhi also. And let's suppose I want to change his age. I write here student. I put this box bracket. I write age over here. Then I put is equal to. Then I want to change his age to 23. And his age will be changed 23. But how would you know? You need to print it over there again. As the other one, the printed ones are containing the values related to the information above them. So here age is changed to 23. And if I want to delete something from it, let's suppose I want to delete the Delhi thing. Okay, Del student age 23, and I want to delete its age 23. Um, some syntax error. Oh, I don't need to write this. Only age 23 age. It is going to remove its age from it. So equals city and name is over here. Its age is deleted from the dictionary. Dictionaries are mutable. We can change values. And here are some useful methods that can be used in our dictionary, namely keys, items, and get and pop. These can we can use like for getting the name of key, getting value, items, and getting something from it. And pop is for removing the value from our dictionary. And what is the here we can know the difference between list tuple and list tuple sets and dictionary. List we have done in last one. Tuple set dictionary we just did. Now let's just compare all of them and know what is the difference in all four of them. See, ordered. Lists are ordered. Tuples are also ordered. Dictionaries are also ordered. Set is not ordered. Okay. Notable. We can edit this list also, set also, dictionary also, but we cannot edit tuples. Duplicate values are only allowed, not allowed in sets. And see, in dictionary, values can't be same, keys can be same. Like in the dictionary we created, we have written name and then name value Rahul. Okay, you can repeat the word name, but you can't repeat the value Rahul. That can't be duplicated. That that is duplicate value. That will not be allowed in there. Okay, indexing. How we can just know indexing? Okay, indexing will be allowed in lists also, tuples also. In sets, indexing is not allowed. And dictionary by key. We can know the indexing by key only. We have to mention the key for doing the indexing. Okay. When should we use them? What's the use of all these four? Like, you might be thinking we can use any of them. Then we have these four different things. We can just use anything. But no, here we can know it when to use which one. Okay, use list when data change frequently. When you have to change data again and again, frequently it changes, then you can write make list. Okay, and when the data is has to remain fixed, it will never change. Okay, it then use tuples. And when you want no duplicates to be there in your data, use set. And dictionary when you have labels like name, Rahul, age, like that. For all the values, then you have to use dictionaries. Okay. So here is a summary. Tuples have fixed collection. Tuples are fixed collection. Sets are unique collection. Dictionaries are key value collection. Alright. So here are some programs that we can write. Fruits are here, print fruits, print type of fruits. You know, string, is print string? Oh no, it's the type of fruits it's asking. So what type is it? Is it tuple? Is it set? Or what is it? You wanna find out? Let's find out. Fruits, then common, banana, orange. Alright, I want to print fruits and type of fruits. Couple object is not callable. Can't get. Oh, I wrote it reverse. First we have to write type and then we have to write the name of the thing. Here I will write fruit. Here I will write type. Mm, Here when we see it is telling that the class is tuple. This is the type of copper tuple. Okay. Tuple indexing. How can the indexing be known? It is similar thing. It is similar for all of them. For lists also. Okay. Suppose also for everything when we have to find the indexing we just write print. Inside bracket we write the name of the tuple list or whatever it is. And inside the bracket we put a box bracket and then we write the index number that we want to print. Now we have tuple methods. Numbers are given here. Print numbers that count to. In this way, we can count that how many numbers of 2 are present in this number. And number index 6. At the index 6, whatever will be available in this thing will be printed in our output. Next comes our set operations. Here we can add the color, can remove the color, we can change sets. So this is how we just change them, remove anything in them, and then print the final output that will have all the new things that you have added in it, like added or removed in it. Whatever in that thing. Now set union and intersection. This we need to do. First we write the two sets. In maths we have done like unions and intersection and all. And whenever you write your set in maths also you write a curly bracket. Remember? So this is how you can remember to put a curly bracket only then it will be defined as a set. Okay. Here it is doing union, here listing intersection and difference. Just write two sets and perform all these functions on it. Here I'm writing like set name, let's put it A only for remembering pop. Alright, 2, 4. Even if you repeat any value in this, it's fine because it is not going to take any duplicate values. Remember, okay. B, let's put 2 again. 5, 5, 9, 7, 5, 6. Okay. Print A dot union and bracket put B. Now print it. 2, 4, 5, 6, 7, and 9. When we put a union of all these, we get these values: 2, 4, 5, 6, 7, and 9. And when you do intersection dot intersection B, 2, 5, 6, and 7. Okay. Now when you do difference, so difference between A and B. Okay. So here is like creation of dictionary. We have done this one, right? We know how to create a dictionary. Just put label also. Labels like key and then value. Key value, key value. Just like that, and put a curly bracket. SS dictionary value. How to SS value? We did this one. And get. Student dot get age. Like this also you can find specific values from it. Update dictionary. How can we update dictionary? These things we did above. Okay. Traverse dictionary. Only these two are left. Okay. Traverse dictionary. So first we are given a dictionary. Okay. And its all values are given over here to us. So first group. Whenever we are using a loop inside a dictionary, that is traversing the dictionary. For key, comma value, key and value pairs are there. In student of items, print key, then this column. The key will be printed, then column will be printed, whatever key is it, and then value. So it is basically a loop that we are applying. Okay. So let us first write the dictionary over here. The name of the dictionary will be student. Okay, and we put a curly bracket. Then we go like label is name, the key is name, and then we put a colon outside it. And we write the name outside the name section. And then we put a comma. We go in another line. And we write age. For age, after age also we put a colon. And we write the age let be 34. And again comma. Then city. We put a column and we let us take the city to Louisiana. Okay, we have created a dictionary over here. After this bracket, we'll just go and write for key, comma, value, and student dot items. Okay, print, we write key over here, then comma, then inside brackets we write a colon, after comma we write a value. So, in this we have written that just print all these values that are inside this dictionary as name of the key, then a colon, and then the value. Like student dot items, it means that all the items inside the dictionary are going to be included in that. Okay. So it is going to take everything like this without any inverted commas. It is going to take only the name of key and only the name of value. And between that, I have written this thing inside the inverted commas. It means that it is going to print it as it is in that. So the next thing we have here is student information system. How we can have a student information system, like this something besides a letter asking.